Hey, okay. So in this, first of all, this is today's Thanksgiving in the United States. So happy Thanksgiving to all of you that are watching this and live in the United States. I've been wanting to do this video for a very long time. In this video, I want to talk about how to create objects in the Revit environment, like walls and views and sheets and other stuff. Um, my goal for this video is that basically talk about the basics of object creation in Revit. I will show you some examples, but I'm not going to write any script right now because I want to make sure that the basics of it is really understood well. And then in the future videos, I can create some more examples and tools that create different types of objects in Revit environment. So the first thing that I really need to talk to you about is the difference between a method, a normal method, and an object like this. Let's say this is a class, a normal method, and what's this called? That's a special type of method that's called a static method. Um, as you know, we can in Python we can define static methods and we can define normal methods on a class. Let's say I have a some class object. When you instantiate it, it sets the x, y values to the values that are provided inside the init. So when you say object, let's say some class, you can provide some value, let's say 10 and 20 to it, and they'll be passed to the init method. It'll instantiate these two parameters, and then you have all these methods that you can use. But as you know, you can write normal methods that you have to provide the self argument to it, or you can write static methods that you don't have to provide that self argument to it. The difference between these two is that the instance method, you have to call it from an instance of that class. For example, that O is the instance of that class because we just created one object from that class. So now you can say O instance method, and you can call it like that. But the static method, the benefit of a static method is that you can also call it from the class itself. So you can say static method like that. To call a static method, you're not required to have an instance of that class. You can call it from the class itself. Now, how is this useful? What's the benefit of this? Let's talk about this because this is very important when you actually start creating objects in Revit. Let's see what happens when you actually compile this class. If you create this class in, let's say, in Python or C#, and you give it to the compiler or the interpreter, and it converts all your code basically to binary, to the machine language, and then it creates a piece of binary data that it places in the memory for each one of these. So let's say the static method goes here in the memory, and that's your static method. And then your normal method, which is the instance method, let's call it, it goes also into memory like that. And then you go and create, let's say, 2 instances of that class object. And they'll also go someplace in the memory. Now, this static method, let's say we saw the code for it, but let's say the code is like this. You can call it directly without providing any arguments to it. The difference is this between the two. The method that is an instance method requires a self argument, the first parameter. You can actually name it anything you want. It doesn't have to be self in Python, but it requires that. Why? Because it knows how to operate on instances. So let's say this is the code for that method. When you pass that self to it, that self is basically a sort of like a pointer to the location of that object in the memory. So when you pass it to it, the code inside this method, the binary code that's been compiled, looks at that and says basically goes into that memory location and then finds the x parameter and operates on that. So if you pass this as the itself, the code inside this works on this instance. If you pass this instance number 2, let's say, The code operates inside this because that pointer, that self pointer, is pointing to this object, and thus the value of x that's being returned inside the code is completely different from the other one. That's what's called an instance method. Obviously, the actual implementation of this, and it's a lot more complex than this. I'm simplifying it. Static method doesn't require that. And because it doesn't require that, that sort of like a pointer to an instance to be provided to it, you can actually call it from the class. So when we say call it from the class itself like this, it means calling this binary code in the memory directly without providing any instance information to it. Because the code inside it doesn't really need to know anything about an instance to get values or look into its properties and stuff like that. That's the general difference between these two parameters, between these two methods. Now, obviously, some of you might know that in Python, we also have a special type of method that's called the class method, which requires the first parameter first argument that's being passed to this method is actually the class itself. So a class is being passed to it, and then you can return an instance. You can create an instance of that class inside it, set some parameters or values or whatever you want to do with it, and then return it as the result value, return value. Now you can go ahead and read more about this, but we're going to focus on the normal instance methods and then the static methods on this one because of the similarity of the static methods between Python and C# in terms of like naming them. So how does this connect to Revit? Revit itself, let's say this is Revit, and you have two documents open inside that Revit. Each document represents a database, as we talked about before. Now, you have this layer on top of everything, which is called the API, which is the Application Programming Interface. Now, your script is sitting somewhere, let's say, somewhere around here, that uses this API to directly talk to basically, through the API, make adjustments to the database, to the document, and whatever, create elements, delete elements, read content, and stuff like that. Everything that we have talked about so far. Now, the way you get access to this document is that Revit provides an API object, that's a document object, that wraps that database inside it. You won't see this internals of this database. The only thing that you see is that document object, and then provides that document object to your script. For each one of the documents that's open, obviously, you get a different document object. You also have a bunch of other classes and types inside that API. Like, for example, a wall is a type, is an object inside that's provided by the API. It wraps a wall inside that the database, and it provides some functionality like reading its height or materials and properties and stuff like that. That object, that type, is also provided to your scripts, so you can use it. This is the API, is basically the interface that you can interact with the actual databases, document databases in Revit. Now, one of the things that's really important about the API is that so far, I'm pretty sure most of you are familiar with this DB because we have used it in the previous videos, and I'm sure you've used it to read information or create, create objects and stuff like that, and basically interact with it with the Revit API. This is this namespace, the DB namespace, is the namespace that has the majority of the objects that you might need to use. Like, for example, the wall object is inside this. I'm gonna go scroll down to find this. It's way towards the end. Or a view or a wall, let's say. Yeah, the wall class is here inside that namespace. Now, this namespace also has a type that is called the document that we talked about. So document class. See, when I look at this, it says that it's inside the Autodesk Revit DB namespace. When you look at the methods of this, this is the list of the methods. You have some, export functionalities, some, some methods to read information from the database, importing, and some other methods, loading families and stuff like that. There is, however, another document class in the Revit API. If you go back to the namespace that's called the Revit creation and open that, you see there's a different document class in here. And if you open that, go to the methods, pretty much all the methods that is inside that belong to this document class are new type of methods. They create things within that document. As an example, you can see there's a lot of these different methods. So what we talked about, what I showed you basically, is this document providing new whatever methods to create elements inside that database. Let's say that's this method creates a wall. There is a challenge though. If I go to Revit and open this and ask my Revit for the active document, the UI document. This is the active document. So I'm going to set that to doc. I've actually done this before, but just for the sake of presentation, doc, and I say new. There are no new methods in here, but I definitely know that that's a document class. But see, that belongs to the DB namespace. The way to get the create is that use this document, because this is the wrapper around the actual database that's inside Revit. That's the only document that's being passed to you. But that document, I should really show it to you in the in here. See, I'm going to go document class Revit DB, and I'm going to go under its properties. If it actually finds it. That's super slow. Anyway, this is slow. So this document from the DB has a property that is called create. Look at the notes here, the tooltip here. It says create parentheses self document. You would think that's a method, but that it's really not. See that get in front of it? This is a read-only property that's defined in C# like that. So when I use that, the return value is a document that belongs to the Revit creation. So let's call it creation document, for example. And I'm going to say dot create, and I'm going to assign it to that, and I'm going to say c dot, and then there you go. You see all these new methods on that document class that can help us create stuff. Like, for example, new room. We can create a new room inside that document. So this is the first. This is one of the two ways that you can create objects and elements inside Revit's database. However, there is a problem with this method. The problem with this system is that the document object or type needs to have that method on it, and it really needs to understand what a wall object is to be able to create one of those. And this creates a lot of complexity in the API, because then you have two objects that needs to have a really deep understanding of each other. And besides, there are some parameters inside a wall that might be private and might be very internal to it. And to create a new wall, this document type might need to have access to them to set them up correctly and stuff like that. And this is basically overreaching inside another object to set it up. The better way to do it is to have a method on that object type itself, like the wall itself, that can create an instance of a wall inside the database. And this is the better and the second way of doing and creating stuff in Revit's database. So let's look at this. Let's say, just to show you something that's very important, if you go under creation and you go under document class, document methods, the new methods that we talked about, This is 2015 Revit API docs. So let's see. Let's go scroll down. See, these obsolete. Autodesk is slowly moving these methods to the better system, which is this inside the actual objects. Slowly, basically obsoleting them and moving them to that instead of providing this document creator, because that's the other one is a better way of doing stuff. So in 2015, they obsoleted these methods, and in 2016, a bunch of other stuff. A bunch of other methods in 2016, and you can go through this whole thing and see all these methods that being removed from the API. And so when you use one of these, let's say in 2018.1, new electrical system is being removed. So when you click on it and you go to its documentation, see the obsolete attribute. Oh, I'm sorry. The obsolete attribute. This is the comment that it tells you whenever you want to use this, that this method is obsolete in Revit 2018. Please use electrical system.create instead. And if you see these notes on all these removed methods, you'll see the same note that this creation functionality has been moved to the create method that belongs to that object type. So this is the first place that you should go. Find the object that you want to create. See if it's got a create method. Use that and learn how to use that to create it. If not, check the document inside the creation namespace and see if you can find your new method there. And make sure that you take a note of this, because probably in the future Revit versions that function is going to be removed and your script is going to break. So make sure you make a note of this. So every time there's a new version of Revit is coming out, you go in and double check that these scripts are running properly. So we talked about the new methods, the new object type methods on the document, and the create on the wall itself. Now, here is where what we talked about static and normal methods tie into this concept. Let's go and find for example, wall object, wall class inside Revit's API documentation. Open the methods and find the create. Oh, actually, there are not many methods on this. Okay, there we go. These are the create methods. There are different versions of it for basically providing different sets of functionalities. You can create a wall based on different sets of parameters. When you're using this in Python, you only see one of these. You don't see that many different versions of that method, obviously. So when I say wall create, there's only one create. But based on the input data that you provide, the arguments that you provide to this method, Python picks that version of that function correctly for you to be able to do it. But what I wanted really to show you here is that little s in here. If I hover over it, it says it's a static member. What does it mean? It means to create an object, you don't have to have an instance of it already, which completely makes sense. When I want to, let's say I want to create a wall, I can call create on the class itself. I don't really have to have an instance of a wall, find it in the model, and then call the create, because that would be a very bad idea. The beauty of this is that these create methods, they're all static methods, so you can call it from the class itself. So literally in your Python code, if you have imported db, you can say db wall.create. And then provide the arguments that are necessary for that function to it. And what you get in return, basically, I'm going to remove all this stuff in here for clarity. So you can say wall instance equals that. So obviously, after you provide all the arguments to the correct arguments to this static method, what it basically returns to you is an instance of the wall that's been created inside the database. And what this create really does is that it goes inside, it talks to Revit's database basically in its own language. This is the part that you don't have any control of. That create function on the wall type, it talks to the database, creates that object, returns that, creates an instance of this wall type that wraps around that object and returns that to you basically. That you can use. It's got an ID, it's got a unique ID, and you can read the properties and stuff like that. It's got its location. It's basically everything just like a normal wall that you find using a filter element collector or anything like that in your Revit. So from now on, the most work that you have to do is to find that create method on that type of object that you want to create, and basically look at the type of properties that it required, and then provide that that arguments to it. For example, 90%, 99% of all these create methods start with the document, because the wall itself, the wall type itself, is not an instant, it's the type. So it needs to know, the create method needs to know which document you want to create this in. So obviously you have to pass the document to it. The rest of these stuff are heavily customized and very specific to that type of object that you want to create. For example, this type of method, this implementation of this method needs a list of curves to create that wall for you. And there's a Boolean argument at the end that says if you want to make that wall structure or not. And when you go to the definition of the parameters, it basically explains exactly what these parameters are, what are the types, and you create this parameter, the arguments, and you pass them to the create method, and it would return the created wall for you. Now, let me show you a couple of examples of these creation methods. So in this script that I've made these before, but I'm using these to kind of show you an example of how this creation system works. So this script creates different types of views based on the view type argument that I'm providing to that function that I've written, the view name, and then the view scale. So it creates different types of views. So I'm going over the view type and saying if it's a floor plan, create a floor plan. If it's a reflective ceiling plan, if it's a section, if it's an elevation, if it's a draft. So based on the type of the view that I'm requesting, this function creates different types of views. Obviously, everything is inside a transaction because you are dealing with the database. You're creating stuff in the database. So you have to encapsulate this in a transaction. So let's say, how do you create a floor plan? Well, view plan is the type for a floor plan. That's an API type. That's db.viewplan. And it's got a create method. I pass the document to it. What it needs is the view family type ID and the level ID. So it needs to know what type of view you want to create, a type of plan view basically, and what level do you want this to be associated with. And to get the view type ID, I'm asking the document, one of the standard methods that it has is get default element type ID. So, and I'm passing that argument to it. And basically, I'm asking the document, what is the default floor plan type that the user has set? So when I'm creating a view plan, I'm creating it with the default type. Same thing with the reflected ceiling plan. See, it's the same thing. It's the same type, because RCP is also a view plan. A lot of times these types encapsulate multiple different types of objects that are very similar to each other. This helps the software developers maintain one object only, instead of having, like, for every little thing that's inside the database, creating a completely different object would make it very, very troublesome. But basically what's happening is that in this one, in the top one, the view type that I'm passing to the create method is a plan view type. Why? Because I'm asking element type group view type floor plan. But in this one, I'm asking element type group view type seating plan. So I'm asking the document to give me the default RCP plan type that the user has set and passing it to the view plan. So the view plan knows based on what type of view you're passing to it, needs whether it has to create a plan view or an RCP view. Obviously, other types of views are completely different. Like, for example, for section, you have to create a bounding box. You have to create, you have to basically set up the direction of that view, and then again pass the type to it. But it doesn't need a level like a plan. It needs a view direction. It needs to know which direction it's looking at. And the type of object that's that encapsulates a section is called a view section. You actually, yeah. And then, for example, for drafting view, it's view drafting, create, document, view family type ID. It really doesn't need anything else because it's just a drafting view. It needs to know what type of drafting view you want to create and in which document you want to create it. And see, in all these instances, the return data would be that instance of that destination view that I've created, that I can go in and play with its parameter and set its view name and scale and stuff like that. One of the things that I wanted to mention is that, for example, this elevation, creation of an elevation, sometimes because of the the way the API has been created before and stuff like that, some of these objects are slightly different from norm. So, like for example, the elevation, you can't really create an elevation directly. You have to use the elevation marker type, call the static method that's create elevation marker on it, and then pass the document to it, the view type, the location of it, and the index of the basically because you know that the elevation markers have different points that they can look at and stuff like that, and then basically create the elevation based on that. So you get the elevation marker and then ask the elevation marker to create the elevation view for you. So creating an elevation is slightly more complex. Don't expect everything to work, beautifully just as we described with all these create functions. Sometimes you have to dig in a little bit more. But the majority of objects are like this, and the Autodesk is actually working towards, making everything uniform and making it super easy to create all these different types in it, in the types of elements in the Revit database. Another example here. This is, what is this? Oh, this is tagging. So, for example, for tagging, see, this is another example that I was using, that I was telling you about. So, I might have written this script a long time ago. So instead of using the independent tag dot create method, the create method on the tag itself, I'm using the document create, that document that belonged to the Autodesk Revit creation namespace, new room tag. I'm using that method to create the tag on the object that I want to create it on. In this case, it could be a space, it could be a room, or anything like that. Obviously, sometime in the future, this function will break. It might have been broken already, but I have to go and fix this later. Another example is the match button. What did I want to show you here? Oh, sometimes, okay, there's sometimes, like for example, there are some objects inside the API, like override graphic settings. These objects don't have a representation inside the database itself. You create an instance of these objects, like for example, I'm creating that source style, and I'm setting some parameters on this, and I'm passing this to an element to set the override graphics on it inside that view. But this object itself doesn't have a representation inside the Revit database. It's a helper object that basically encapsulates a couple of parameters that you have to pass to the create method or other more advanced method to basically set the pass some values to it and do something. So not all the types that you see in here, like that specific type, is not a that specific type is not actually a descendant of an element. So if you go and find this object type, you see that its parent is not Autodesk Revit DB element, it's just system object. So this is not a type that represents an actual element inside the database. Another example would be orient to face. For example, on the same lines that we talked about, that sometimes you have to create an object to be able to pass some parameters to another method. In this example, what I want to do is to create a sketch plane inside the Revit database. So I'm using the DB sketch plane create. So that's the right function to use for it. I'm passing the document to it, but it needs a base plane. To create that base plane, I have to create a DB plane object that doesn't have a representation inside the Revit database and document database. It's an object that describes a plane in space. So I have to create that. I have to give it the normal vector and then the face origin, the point of it, the origin point of it, and then create that and then pass it to this. And basically, the sketch plane create method understands that it needs to create a sketch plane on that plane in that 3D space. So it uses this base plane information to understand which plane do you really care about. Otherwise, you had to provide like 20 different arguments in here from the all these other arguments that you pass to it. You have to pass them here. So this basically provides a lot better um, interface, because like this create function, for example, can run methods on this plane. Like for example, if it needs to know its area or something like that, because it's a more advanced object, it can provide other information about it too. So when you pass this to it, if in the future the Autodesk developers decide that they need more information about it, by updating that plane, they don't have to really change anything. The no changes to your scripts would be done. This is basically a way of encapsulating some of the information that you want and passing it to another create object, another create method to create, like for example, a sketch plane in here. All this might sound a little bit complex, but when you actually start using it, it's a lot simpler than that. Another example is the view set. For example, you know that the print menu in the print window, you can set create sheet sets or view sets and stuff like that. So this is how you would create it. The view set object doesn't have a representation inside the document database. You can create one of these, and then I'm iterating over a set of views and inserting that view inside that view set, and then later setting that view set as it's actually here. We're creating the print set as the current view set views. I'm setting that as the active current view set. So you see, I'm not using any create method or anything like that, because it really doesn't have to. It's not as complex as the other objects. These are a lot simpler. It really depends like how much information you have to provide to that object to be able to create one of those. Another example is creating of sheets. This is actually the source for the tool that I have under Batch Sheet Maker. This Batch Sheet Maker can create sheets or placeholders. And the way to do it is that you can see that I'm using the same view sheet object to create a placeholder and to create a sheet. It's the same thing. But there are two different types of create methods on it. There's one create and there's one create placeholder. I'm actually going to go and show this to you here. I'm going to go on the methods and see there are two different types of creates. They're both static methods. Create creates a view sheet. Create placeholder creates a placeholder sheet inside the document. So this is another example of like one type wrapping two different types of sort of like objects inside the database. So I'm using that to create a different placeholder and the sheet. Obviously, the placeholder doesn't really need much information other than the document, but the view sheet needs the title block ID. It needs to know what kind of title block you want to assign to the sheet. Some of these methods, some of these arguments, you might be able to pass null to them. So let's see the implementation for this. See, for example, it says the type ID of the title block type, which will be used by the new view sheet. For no title block, if you don't want to have any title blocks, just pass invalid element ID, and that is because this is an element ID, the second argument. That is basically this. Every time you need an invalid element ID, you can ask the element ID type itself for the invalid element ID. This is your invalid element ID. Generally, it's set to -1, but obviously you should always use this because the correct final actual value of it is implementation dependent. Autodesk can change it at any time. You should use this always. Invalid element ID. Anyway, I showed you a bunch of examples of how to do this. Just to quick wrap up. First of all, find the object that you want to create. Make sure it doesn't have a create method on it. If it doesn't, most probably you can just call it, create an instance of it just by calling the constructor. So if it doesn't have that, just like lots of view set. Like view set, you can just call it like that. And you basically get an instance of it. Man, this is really slow. you get an instance of that. So you don't really have to use any static methods on it. But you'll be able to see this in the documentation. It's perfectly clear. And then if you couldn't find anything like this, look into the Revit creation namespace, the .document object. Obviously, it's the doc.create, and then see if it's got a new method on it that you can create to create your, and then find it in the documentation, and then see what kind of arguments do you need to pass to it and stuff like that. And that's basically it. The last piece of information that I want to talk to you about is that a lot of these objects, for example, let's go back to that wall class and look at its create. Look at its create method. So let's say this one that we talked about. You can see that for the profile of the wall, you have to pass a list of curves. Now, if I open the documentation for list, it'll go to a place that is the MSDN. This is not Revit's API documentation. This is Microsoft Developer Network. Why? Because this is a standard C# type. Revit API didn't create another type of a specific list for anything like that. This is a typed list that is perfectly capable of handling a list of curves. But when you look at the curve class, that's an API. That's a Revit API class. So basically, in a standard typed C# list is providing a list of curves to the wall, to the create. Now, here's the trick. Let's say you have a list of all these curves. Let's say, I'm just going to use numbers right now, but let's say curve list. Side. Let's imagine each one of these numbers is a curve. 1, 2, 3, 4. Let's say I've got 4 curves. You cannot pass this to that create method. Why? I'm actually going to use the type method on it. This is why. Because the type is the Python list. Its type is not a C# list that is also typed. The major difference between the two is that lists or other collections in Python, they don't care about the type. You can put any, so you can put a string in there, you can put an integer in there, you can put a Revit wall in there, all combined within the same list. You can't do that with that kind of list. That kind of list only accepts curve objects. So how do you create that? This is IronPython, so you can use and bring all the types that you need from the C#, from the .NET framework, basically. So for the list, I'm going to say from system .collection generic import list. And the way I know this is that this tells me that the namespace for that type is that. And a lot of times you see that I in front of it. Don't worry about that too much. That means that's an interface. You can just use it without the I. You can use that. So I'm going to say list, and I click on it. See, it says type list square brackets T. Now, this is different from what we saw here. Python doesn't understand these. These are operators to Python. So the people who implemented IronPython very, very smartly used square brackets, which is an indexer for Python objects, as this basically. So let's say I want to create, let's make sure I have the curve object imported. Yes, that's the curve. So I'm going to create a curve list. I'm going to say I need a list of curve. I'm going to do that. So now CL is a list of curves. So this object is a C# list that only could include curves, basically Revit API curves. You do the same thing for creating, let's say if you want to do UI doc selection dot set element IDs. See in the note says it needs an I collection of the type element ID. That's how you pass. You need to pass a list of element IDs to it. If you just create a normal Python list of element IDs, even though the element IDs inside that list are all Revit objects, it's not going to accept this. So what you have to do is that you have to do this and say element ID. I need to create a C# type of list that could have element IDs in it, and then do this, and inside this provide your Python element ID list that we assume that. So this would be the list of the normal Python list of element IDs that you have collected. You pass it to this, to the constructor for that list. It understands, it goes through all those objects, grab the element IDs, puts them in there, creates a list of element IDs, and then when you pass it to the set element IDs, you won't get an error because that's the exact type that it needs to have. So this is the last thing that I wanted to mention really, is that sometimes you see the arguments that you have to provide to these methods. They're actual .NET Framework types, and you kind of have to learn around it inside inside IronPython to be able to know how to create these types and pass them. I hope this video has been useful. In the future videos, I'll actually write some scripts and show like how we can actually create a couple of these objects, and then we'll take it from there. And if you have any ideas about any type of object that you really want to know how to create, just let me know in the comments, and I'll put that on the priority. And hopefully, hopefully in those videos I will be able to actually hands-on show you how you can create different types of Revit objects. Thank you.